Alright, here we go. I just had a call this morning to see if my ISP could fix the internet disconnection issues with rain and wind. But it seems that hasn't been resolved yet, but I might be able to get an upgrade on that. That'll be fine, whatever. But, alright, to do what today, right? My plan is to do one Leetcode question, then do quite a bit of study. It'll be predominantly study, and then following it up with the Odin Project, and possibly going to the gym at any point in time between then. But yeah, the whole day ready to grind it out. And yeah, let me just now do a monkey type question. Signed out, sure. Firebase. Okay, that's a monkey type issue. Whoops. Okay. So Leetcode is going to be the first thing I do here today, just so I can get it out of the way. Might not even need this actually. So look, trees, invert binary tree. Depth first search. Invert the binary tree. You're given a tree with a root node, left and right. I guess you can invert each level. It's going to be depth first. Alright, root left becomes root right, and root right becomes temp. If it's not going to work because I know there's going to be failures. Root. Rate limit exceeded. Damn. If not root, return none. Root left. Root right. Right. It's 3-minute problem solved.
Hey everyone, welcome back.
Let's hopefully see this.
Right to one so today let's solve a pretty easy and popular question: invert a binary search tree. So all they tell us to do is invert a binary tree. And what exactly does that mean? So let's say that this is our initial tree. To invert it is basically what you can tell in the output, right? So the root stayed the same, but you can see it's two children, which were left child 2, right child 7 were swapped, right? So 7 is now on the other side, 2 has been moved, right? So basically, simply can be swapped. And when they say invert the binary tree, they refer to everything. So take a look at this subtree, right? You can see since we moved it to this side, that's where it is, right? But notice how even these subtrees are different now, right? 1 was initially on the left and 3 was initially on the right, but now 3 is on the left and 1 is on the right. the exact same thing happened with this tree, right? It was moved over here to the left side, but then its children were also swapped, right? So 9 was moved to the left, 6 to the right. So when they say invert the binary tree, what we're saying is visit every single node in the tree, right? And every time we visit a node, take a look at its 2 children and swap the positions of the children, right? So in other words, if we're given a tree, look at the root. So in other words, if we're given a tree, look at the root node and take its children and then swap the positions, and then recursively run invert tree on the left subtree and run invert on the right subtree. So it's a recursive definition. So we can solve this problem with recursion. We can do a depth first search, whether it's pre-order or post-order, it doesn't actually matter. A depth first search will allow us to solve this problem recursively. So this problem would probably be a lot more annoying if it were iterative, but luckily we can do it recursively. So we can first check the base case. So if the root is null, then we can return null. We don't have to continue. Otherwise, what we're going to do is swap the children. So we're going to save the left value, root.left, in a temporary variable. Then we're going to replace the root.left value with root.right, and then we're going to replace the root.right value with the left value, which we know is now stored in temp. So after we swap the nodes, all we have to do is now recursively invert the subtrees. So we can invert the left subtree, and then we can invert the right subtree. So by doing self.invertTree, what we're doing is making a recursive call to the function we're inside. And once we have swapped the root's children, once we have inverted the left subtree and inverted the right subtree, we know we're finished, so then we can return the root. So there it is. This problem is relatively short code. It's a very good problem to kind of understand the basics of depth first search and
maximum depth of binary tree. Alright, let's go. Okay, given the root of the binary tree, return the depth. The depth of binary tree is defined as the number of nodes along the longest path from the root node down to the farthest leaf node. So if you go to root 1, 2, 3, null, null, 4, and nothing. So let's see, how do we want to do this? Would we need recursion still? Possibly. So max depth. Right, you might need to use max depth on the root left and maybe max depth on the root right and R L if return max of L and R if root return if not root return 0 And if it's 0, you return 0, but how do you increment any of this? Max depth. Plus 1. So if it goes to nothing, then you add 1. Two, 3, 4, 5. You take the max of any of the two. I think that would work. Max depth. Man, I'm too good at these questions.
Hey everyone, welcome back to Inverting on Leetcode today. So today let's solve the maximum depth of a binary tree, and the main reason I'm solving this today is just for the sake of completion. We have solved harder tree problems before, but this one is on the line 7 so I do want to solve
Sure.
this problem today.
Ah, Samem Mohammed said Leetcode. Oh no. It's alright, I actually did these questions. I did 2 just now, both for binary search. Both easy, but still. Not bad.
And this problem actually has multiple ways to solve it, so I do think it's a good problem to understand of like the fundamentals.
Just had an interview this week? Fair enough. Which one? Which company? Leetcode PDST.
Basically depth first search without using recursion, and
Man,
of course,
nice, you got a Microsoft interview.
breadth first search. So I'm going to be showing all 3 today.
Congrats, man. See how it goes. Best of luck, Hide. Hope you get it. A good outcome.
So the problem is pretty simple. We're given a root binary tree and we want to return its maximum depth. And the maximum depth is defined as being the longest path from the root to one of the nodes, to one of the leaf nodes, and
Got the get the longest path. I'm guessing palindromic substring problem. Oh, I see. That would be a what type of problem would that be? Because I do remember doing that type of problem. Maybe it's a 2-pointer problem. I forgot. But get the longest palindrome. Yeah, yep. Epic. Of a substring. Isn't that like a hard problem as well? Hopefully it went alright, to be honest.
basically along that path we're counting the number of nodes. So in this case,
Yeah,
we
medium.
have 2 paths that are of the same length. So from the root down to here, we have 3 nodes. From the root down to here, we have 3
It was
nodes as
fine.
well. So those are
Okay.
2 leaf nodes
That's
down
good then.
here. We also have a leaf node on the
Hopefully
left
you
side,
get
but
it.
clearly we see that there's only 2 nodes in this path. So out of all those paths, what's the max length? Of course it's 3, so you can see that that's what our output is going to be in this problem. So the simplest way to solve this problem is recursive depth first search. Now, what's the base case? We're using recursion, so first let's think of the base case. Obviously, if we had just an empty tree, right? Like what if this was our tree? What are we going to return? Of course, 0, right? The max depth of an empty tree is just 0. What about if we just had one node and no children, right? okay, we'd do this recursively. So we'd get to the first node, right? We'd say, okay, we at least have one node. Then we'd say, okay, let's just find the max of the left subtree and the max of the right subtree. Both of those are going to return 0, right? So once we get back to the root, what are we going to say? We're going to say, okay, the left and right subtree were 0, so the maximum of the left and right subtree is also 0. So what we're going to return from the perspective of this root node is just going to be 1 plus the max of the left and right results. Basically the max of the left and right subtrees, in which case it was both 0, so of course in this problem we're going to return 1 as the max depth. Now let's look at this more general example that they gave us. So obviously we're going to do the same thing. We're going to get to the root, say, okay, we found at least one node, so the depth is at least 1, and then we're going to return the max of the left and right subtrees plus 1.
Oh my god, I had no audio that whole time. Oh wait, no, that actually, yeah, when I was, okay, thank you for letting me know. Alright, yeah, I got it. What was it? So you said, do you do something else other than Python? If you're talking with respect to Leetcode or Leetcode, nope, I only do Python. But you know, I've heard good things about C++, doing it with C++, because you have more control. But I will maybe at some point do that. But okay, no, in more general, I do C++. Here's the thing, I haven't even learned C++. I've learned C, right? So I know C, I know Python, I know a little bit of JavaScript, and I do TypeScript React with the scheduler app that I'm building right now. So this is like my main concern at the moment. You did C++ in 2011 to 2013. Well, you don't like it then? What, brings bad memories or something? Anyway, languages, right? TypeScript, Python. I'm using Python as a backend in this project that I'm building. And yeah, some obvious other HTML, CSS, JavaScript. But I'm still learning web development, so you know, I'm a machine learning guy. I used to write ML models in C++ and MATLAB. Damn. Okay, that makes sense. I mean, I'm doing a little bit of machine learning as well, but that's also purely in Python as well. So I think I have it somewhat easier now than you did back in 2011. Possibly. So epic to you. Python makes sense now. As in, Python makes sense for doing ML. I would say so. But if you are to learn a new system language, it has to be Rust. Yeah. So that's the thing. Yeah, the Rust I've heard about as well, and I know roughly about it. Like, Rust's like C, but manages memory for you. At least that's what I've heard. Hopefully that's not too different from what your expectation is of Rust, but yeah, that's my impression of Rust. I haven't learnt it yet, but I feel like, it would be hopefully okay to pick up, just like what I've heard with Go as well. That Go is easy to pick up as well. But yeah, those will be some other languages to learn further down in my lifetime, I reckon. It is very, very difficult compared to Go. I see. I mean, how difficult would Rust be compared to C? Easier, harder? More difficult than C. Alright, valid. Alright, maybe I'm thinking taking it a little too lightly then when I learn Rust. I'll keep that in mind. Invert tree. I can't paste this every time, man. The problem is that if that it is a new paradigm, yeah, a new way of doing things, yeah. I reckon that would make sense, yeah. I mean, let me see, Rust language. Maybe it's good to just have a little read. Damn. No garbage collection, also no default allocation deallocation. I mean, C doesn't have default allocation deallocation, no? Like, you have to still use malloc and dealloc in C. I see. No malloc and like C and C++. Ah, right, yeah, I see what you mean now by no default allocation deallocation. Yeah, okay. And no garbage collection. Like Java, JavaScript, Python. Fair enough. no garbage collection, and no default allocation deallocation. That's kind of mad, no? Have to understand what really goes down in Rust then at some point. And then there's something else like Ruby on Rails that I want to look up as well at some point to understand, at least to a higher level. And I mean, this might be a good video to watch, to be honest, just to understand Rust. 2 minutes is alright.
Memory-safe compiled programming language that delivers high-level simplicity with low-level performance. It's a popular choice for building systems where performance is...
Let me read that. High-level simplicity with low-level performance.
It's a popular choice for building systems where performance is absolutely critical, like game engines, databases, or operating systems, and is an excellent choice when targeting WebAssembly. It started as a side project of Great-on-4 in 2007, who named it after the Rust fungus. It was sponsored by Mozilla in 2009 and has been ranked the most loved programming language every year since 2016. With its fans
Followed by which?
in 2009 and has been ranked the most loved programming.
Followed by Python, Kotlin, Go, C#, and JavaScript. Who really likes JavaScript, right?
Its fans being known as Rustaceans. Traditionally, high-level languages provide a garbage collector to nerf your control over memory management, while lower-level languages provide functions like free and allocate to keep yourself.
Right.
Rust takes a different approach. It has no garbage collector, but achieves memory safety with a concept known as ownership and borrowing.
Okay, so this is the concept you're talking about then.
Default, every variable in Rust is immutable. This allows values to be used in stack memory, which has minimal performance overhead. However, mutable values or objects with an unknown size at compile time are stored in heap memory. Every value in a Rust program is assigned to a single variable.
Okay, let's see, hold on. Let's see. Get back a little bit. So it's immutable by default. It uses something called borrowings / light times. Yeah, so ownership and borrowings. Let's see.
However, immutable values or
Wait, go back a little bit. So immutable by default.
this allows values to be used in stack memory, which has minimal performance overhead. However, mutable values or objects with an unknown size at compile time are stored in heap memory. Every value in a Rust program is assigned to a single variable known as its owner. When that variable goes out of scope, the memory
Hold on, alright, so owner with a value.
When that variable goes out of scope, the memory allocated to it is dropped automatically. In some cases, though, you may want to pass a reference to a different part of the program. Borrowing allows you to access a reference in memory without taking ownership of it. There are
So if that's anything like C, is that not like an address, and it's just a pointer? You know, there's a bit of C in Rust, I guess. Yes and no. Cargo.
To get started, install Rust, then run cargo new from the command line. In the main.rs file,
Damn.
which is where the program will start executing. Declare a variable of let, followed by its name and type. The value can be changed or reassigned by default, so add mut to make it mutable. The name of the variable is
Okay.
a reference to its location in memory can be borrowed by other parts of the program by prefixing it with an ampersand. Then use a macro like println to log the value to the standard output. Rust also comes with a standard library that contains modules to handle I/O, the file system, concurrency, among many other things. Now compile your code to an executable with the Rust compiler. You just built a memory-safe executable that can handle the most performance-intensive system requirements. This has been Rust.
Nice.
In 100 seconds. Hit the like button and subscribe if you want to see more short videos like this. And leave a comment if you want to see a full Rust tutorial. Thanks.
Alright. Fair enough. I can see the value. You don't need to worry about mallocs and deallocs like you would in C. But I'm sure there's way more that in 100 seconds I couldn't yet fully understand. Yep, but you need to worry about borrowing. Yep, it is. So yeah, I definitely do agree on the paradigm shift. It's a different way of thinking. Okay. Insert Control-C, Control-V. I can't Control-V. That's so annoying. I can't even paste. Well, I guess I'm writing it out real quick. Okay. Now I add it here. Invert binary tree, number what? 226. And I know I can do GG YG on this whole thing, and I should be able to Control Shift V. Oh, I swear. No. GG YG paste. Control Shift V. Nope. Control Shift V. Control V. Nope. Can't do it. How come I could do it yesterday and I can't do it now, man? So sad. Man, I have to open up VS Code every time just to do this. I gotta figure out a better workflow to save these problems. Because I'm sure this is all in my clipboard right now. No, it's not. Yo, am I clicking the right buttons? Should be. This is beyond confusing now. It's like nothing is being copied. Man. Sure. So that's invert binary tree, but I'm gonna go back to this one and I'm gonna have to create a new solution. The depth of binary tree, which is 104. Sure. 104 depth of binary tree.py. Okay, and yeah, so we're done both of them now. Both of them are here. Git add, git status actually, git commit -m feat some binary problems. Solved binary problems myself. Git push. Okay, we're good. But okay, I wanted to finish watching this video. So all of this is good now. And close this. And I'm gonna just watch this solution to go recursive DFS, BFS, and iterative DFS. For what I did though, so this is maximum depth of binary tree. I'm gonna just copy this video. And this is also binary tree. You can do it in DFS, BFS, BFS, or iterative DFS, IDFS, I guess. So can do using DFS, BFS, or iterative DFS. I solved it in how did I solve it? I did it in a BFS. No, I did it in a DFS, I believe. Wait, let me see. So you do the left continuously. Yep, until, yeah, this is a DFS. I can solve it in BFS by doing something. What the difference is, I'll figure it out.
And why are we doing it this way? Well, you can see that we found this node, but now we have sub-problems, right? We need to know what's the max path, what's the max depth, and we'll have to search the left subtree, and we'll have to search the right subtree. So we're not even considering this node anymore. We're doing recursion. We're looking at the sub-problem. What's the max depth of this left subtree? Well, of course, it's just a node, a single node with no children, so of course the max depth is going to be 1. Similarly, let's do the right subtree, and so again, this is going to be our recursive case, right? We have one node, and from this node's perspective, we're going to run recursion again. We're going to look at the left subtree and the right subtree, both of which are going to return 1. So then, of course, from this node's perspective, we're going to return 2. The max depth of this subtree is 2, the max depth of the left subtree is 1. So now, when we get back up here, we're saying, okay, from the perspective of this node, we're going to return 1 plus the max of left and right. The max is clearly 2. So from this node's perspective, we're going to return 3. The max depth is 3. So let's code this up recursively. It's literally just going to be this line that I just wrote and the base case. And since we are traversing the entire tree, the time complexity is going to be big O of n. The memory complexity is just going to be the height of the tree, which also could be worst case big O of n if it's not a balanced binary tree. So with recursion, we always want to take care of the base case first. So if the root is null, then of course we're just going to return 0. That's the max depth. Otherwise, we're going to return 1 plus the max of what our DFS of left returns, or in this case it's not DFS, it's actually called max depth, and since we're inside of the function, in Python you have to say self.maxDepth, and then run that on the left subtree, and also run it on the right subtree. Now to make this line shorter, I could actually store the result of both of these function calls in variables, but I think just one liner is pretty much good enough. So we're just taking the result of both of these function calls, figuring out what's the max of it. So what's the max subtree depth of both of the subtrees, and then just adding 1 to it, because we know that the current node, the current root node that we're traversing is definitely not null. So this calculation will work out. Let's submit it. And of course, I'm showing that I can't even solve easy problems, so it's not called node, it's actually called root. Hopefully you were able to catch that. But yeah, so this is the entire problem. So what if you're an interviewer, or what if you just want to do this for learning purposes? You want to solve this problem without recursion. Well, there's 2 ways to do it.
Okay, let's have a look.
Or iterative breadth first search, and I'm going to show you both of those right now. Now, there's not a lot of benefits to using breadth first search on this problem compared to just doing DFS recursively, mainly that you just don't have to do recursion at all. The time complexity is still going to be the same, the memory complexity is still going to be the same, but let's still do this for learning purposes. So breadth first search on a tree is basically level order traversal. We're traversing each level by level until we get to the end or the last level, and then we can't continue anymore. So you can kind of see how breadth first search is a pretty intuitive way to find the max depth, right? We're basically counting the number of levels we have. So here we see, okay, we have 1 level. Next we see we have 2 levels. This is the first level, and we can go lower. So what's the number of levels that we had? We had 3. That's the number of levels is basically going to be the same as the max depth. So now the only problem is, how are we actually going to code this up? Now typically BFS involves a queue or a deck, a DQ or however you call it. And so the way it's going to work is the queue is initially just going to have the root.
I'm going to have to go back a little bit.
By level until we get to the end or the last level, and then we can't continue anymore. So you can kind of see how breadth first search is a pretty intuitive way to find the max depth. So now the only problem is, how are we actually going to code this up? Now typically BFS involves a queue or
Apologies. I am back. Ooh.
Or a deck, a DQ, or however you call it.
DQ.
So the way it's going to work is the Q is initially just going to have the root value. So I'm going to kind of represent this array as the Q. So initially we're just going to put the root in the Q.
Oh, Kizetsu, hello. Hello again.
The length of our Q. These are the elements currently in our Q, and
Just doing a Leetcode problem. I just had to move the car out for mum. But now we're just doing breadth first search. I mean, binary trees.
these are all at level 1. So now we're going to go through every node in our queue. We only have 1, and we're going to take 3. Now we're going to remove it from our queue, and we're going to replace it with its children, 9 and 20. So let's add 9 and 20 to the queue. So now this is our second level, right? These elements that we have here are our second level of the queue, the second level of the tree. So we're going to do the exact same thing with these two nodes. We're going to take the first one, 9, get rid of it. We see 9 is here. Now we're going to replace it with its children. It doesn't have any children, so we don't have to replace it with anything, right? But we're going to keep going. Now we're going to go to the second one, 20, remove that from our queue, and replace it with its children. What are its children? We have 15 and 17. So let's add 15
And 17.
Okay, and 17 to our queue. Now this portion is the next level. It's level 3. So let's continue to go. So 15 is the first one. Let's pop it. Let's get rid of it. Replace it with its children. It doesn't have any children, so it's a base case. Next one, 7. Okay, I wrote 17, but it's...
So I didn't know you had LinkedIn. Just sent the connection from Arnav Survi. All right, I'll connect you. I'll connect you.
7, sorry about that, I'm not paying attention. But okay, we're gonna get rid of this 7, and we're gonna see. Okay, 7 doesn't
I'll remember
have
it.
children either. So now when we continue to go, we're gonna see. Okay, there's nothing left in our queue, so we have to stop. Right? That's how we know we're done traversing the entire tree. We went through every single node.
Yep.
That's the max level that we actually got to. Of course, it was 3, so that's what we're gonna end up returning. The max depth of this tree is 3. Okay, so now.
How do you keep track of the levels though?
Solution. So another base case or the same base case because it's not root.
Hold on a second. Sorry, keep on getting distracted.
So return 0, and we're also going to maintain the current level that we're at.
Turn 0.
Queue, which in this case
Sure.
is going to be a deck, and initially we're going to initialize
DQ.
the queue with just a single value, the root.
Sure.
I think most libraries do have a queue structure, so we're going to initialize the queue like that. We're going to have our level initially at 1. We're going to keep going until the queue is empty, right? And so now we want to go through the queue and remove every element that's currently in it, right? So however many are in it. So we're going to say for I in range, length of the queue at this current time, right? So we're going to take a snapshot
Right,
of
yeah.
the length of the queue. Maybe it has 1 element, maybe it has 2. We're going to take a snapshot, remove all of those, and then add the children. So basically
Gotcha.
traverse the entire level,
Wow.
and add the next level, and then once we're done with that entire loop, we're going to increase the number of levels. So for every node in the queue, we're going to go ahead and pop from the left, just like we did.
I could never figure this out by myself
left of the queue,
if it was
or
depth first
add
search.
the right of the queue. So we're going to pop a node, and then we're going to go ahead and add its children to the queue only if the children are not null. So if node.left is non-null, then we're going to go ahead and say q.append node.left.
Pop
If
left, I see.
node.right is non-null, then we're going to append that one as well. So q.append node.right. And actually, if we're going to be doing it this way, we should probably initialize our level to 0. So you can see that we're never going to be adding null nodes to our queue. So every time our queue is non-empty, we can be sure that there's at least a non-empty node in the queue, right? So we're basically counting the number of times our queue is going to be non-empty. So each time it is, we can basically increment the number of levels. And then at the end, once our queue is finally empty, we know that we have totaled up the number of levels, and we can go ahead and return that.
Damn. Pretend I didn't see this for a second, okay? Pretend we're here. If not root, return 0. Right, because there's nothing, so this is just a base case. I'm going to use a queue. And he did a DQ, something like this, right? But the problem is, DQ comes from like a library, right? That's what I think. Oh, can I even be bothered? I just want to see the solution, to be honest. Or let me just recite the solution. So you put everything in a queue. You take the range of the current snapshot, or you take a snapshot which is just a range of all the values in the queue currently. You pass through each one of those values before you drop them all. Actually, why would you need to pass through all of them? But you go through a range to get snapshots that you can further increment levels of. But yeah, let's have a look at here. So he did a pop left. Alright, you pop the value so that you can add new values into it. Yeah, obviously. And so yeah, he does a DQ here though, and starts off with the root, starts off with a queue, and the level. Yep.
So you can see this solution also works, and it's also pretty efficient. So this is the breadth first search solution.
Okay, but DQ Python. Does that not have to be from collections import DQ? There we go. Alright, that's fine.
But there's one more solution I want to show you, the iterative depth first search solution.
Sure.
Depth first search without using recursion. So now we're going to do iterative depth first search, and we're going to be needing a stack data structure because we're basically going to be emulating the call stack, the recursive call stack, right? So you know, in a recursive DFS, we go to this node, right, and then we go to the left subtree, right? And when we're done with the left subtree, then we pop back up to the 3, and then we go down to, you know, the right subtree, etc.
Yep.
That's like in order DFS. But we're going to be implementing pre-order DFS with a stack because pre-order is actually by far the easiest one to do iteratively. So what we're going to do is we're going to say, okay, come to this node, process this node, right? Then add each children to the stack, the left and right children, right?
Ooh.
Now a normal pre-order traversal will do the left subtree first. So what we're going to do is now say, okay, let's do the left subtree. Well, we're going to go to the left subtree. It's pre-order, so we're going to process this. Then we're going to do its children. Well, it doesn't have any children, right?
Mhm.
So now what are we going to do? Well, this one was added to the stack, so then we can go ahead and process this one and add its children to the stack, and then we're going to process this one.
This looks like binary search. I mean, breadth first search.
And then we can process this one, and then we're done, right? So we're going to do that, and as we do it iteratively, we're not just going to be adding the nodes themselves to the stack, but we're also, for each node, going to be adding the depth of each node, because we can easily do that, right? We know this is going to be depth 1. When we add the left and right children, we're going to say, okay, these are at depth 2. When we add these two, we're going to say these are at depth 3. So we're just going to try to visit every single node, find the node that has the greatest depth, and then we can return that. So
Okay, so a stack and a queue.
At depth 1 in our stack. So now we're going to pop from our stack. So let's pop this node, and we processed it. So far the max depth we found was 1.
Damn. So literally we use stacks and queues
And let's add 9
for both of these
stacks.
problems.
Each of these are going to have
I mean,
depth
for
of
this problem.
2. So now this is technically the top of the stack, even though it's the bottom. So let's pop from the top of the stack. Pop this one. That's node 9. So now we found a max depth of 2. That's better than 1. And now let's also add the children of this. Of course, it doesn't have any children, so we're done with these. So now what's at the top of our stack? Well, we popped this one, we popped this. This is at the top of the stack now, so let's pop this one. We popped 20. It also has a max depth of 2, so we don't update the result. But now we can add its children to the stack. And the depth, of course, is going to be +1. So both of these are going to have a depth of 3. We're going to add 7 and 15 to the stack. So now let's pop the top of the stack, 15. Pop this. It has a max depth of 3, so we've updated the result. Pop one more time. This also had a max depth of 3, so we're done with that. We processed this node, and we doesn't have any children, so now we're done with the DFS. So that's basically how it's going to work. Pretty straightforward, at least if you're doing it with pre-order DFS for the stack. Okay, so finally for the last solution, so this was DFS, but now we're going to be doing iterative DFS. We're going to leave this initial case. If the root is null, we're going to return 0. And our stack, otherwise, is just going to have one single value on it for root. But remember, we're also maintaining the depth, so we're going to add a pair of values. We're going to add the root, which is the node, and we're going to add, it has a depth of 1. And now we're going to continue to go while our stack is non-empty, so this is pretty similar to BFS, but we don't actually need nested loops. So now we're going to pop from the stack.pop. We're popping 2 values, remember, we're getting the node and we're getting its depth. And so what we're going to say now is we're going to say if the node is non-null, you'll see why.
And the other thing that I want to make mention of is the 2 operations that we use in queues and stacks. And in a queue we use pop left. And dot append. And in IDFS we use pop and push, right? Should be, oh no, pop and append. Pop and append. Is that right? I think. Well, let's write it. Pop. So it pops from the right, I'm guessing. And append.
I'm going to do this in a moment because it's possible the node could be null. So if it's non-null, what we're going to do is we want to update our result. Now initially we're going to set our result equal to 1 because we know we do have at least a 1. And so if we pop this node and it's non-null, then we can potentially update our result. So we'll set the result equal to the max of itself and the depth of the node that we just popped. And then what we're going to do is to our stack, we're going to add the children of this node, and we're going to add both of them together. So node.left, node.right, but we're not even checking. It could be possible that these children are null. So we technically might add null nodes to our stack, which is different than the drawing I showed, but we're showing that if we do add a null node, we're going to pop from...
Bro, forgot to encapsulate this in another list.
Right, this if statement will prevent us from actually using that null node. So we're just going to ignore the null nodes. And actually, we're adding both of these nodes, but we also want to add the depth of each of them. So that's what I'm going to modify right now. So we're going to append the left node, and we're going to append it with its depth.
There we go.
It's going to be the depth of the node that we just popped.
+1.
And we're going to do the exact same thing for node dot right. So copy paste and update this. So we're adding both of the nodes, even if they're null, we're adding them. And then we're just going to continue through the stack until the stack becomes empty. And then once that is done, we can go ahead and return the result. And this is
valid
code. And I actually just realized that we can actually simplify the code a little bit. We can actually get rid of these 2 first lines and set the result initially equal to 0. So then if we do have a null root node, the loop will execute, will pop this, but then the if statement won't execute, so then the result will stay 0, and then we'll end up returning 0. But of course, if the root is non-null, we will end up updating the result. So this is the third and final solution that I wanted to show you. They all have basically the same time and space complexity, but there's definitely variations with each of these solutions. So I hope this is helpful.
I like this. Very good.
Like and subscribe, it supports the channel a lot.
You're good.
Hopefully see you pretty soon. Thanks
Okay.
for watching.
I'm gonna close these because we're good. So that's fine. I'm done with that for now. Done with Leetcode. Now, the Odin Project. I'm tempted to start and do a little bit of the Odin Project here. It'll just mean later in the day, I'm going to be focusing more on the lectures that I haven't watched yet. And I'm doing more of the fun things right now, which I don't know if I should. It'll be a bit of an iffy, dangerous choice right now. But, you know, Flexboxes are kind of interesting, and I kind of really want to learn that right now. Versus my alternative, which is a few lectures that I want to catch up on, and also to read up on a lecture before tomorrow's class. So I'll do both either way, but I think I'll go through the Flexboxes first, and then we'll do the lectures. Okay, and then with all that, okay, maybe I'll just commit this. I think I'm fine with committing it, I think. Okay, and then we might need to go back to the Odin Project foundations. Okay, site unreachable. What's this one? Sure. That's fine. It's just the name. Okay, intro to Flexbox. I'm also making note on something before I start here. Might try and like make my own Patreon, why not? Okay. Done. Oh, sucketh ready. Got recommended here by YouTube. Good luck with your journey. Thanks, man. Thank you a lot. Appreciate your kind words. Okay. Intro to Flexboxes. Let's go. Take these off. Take this off. Okay, as you'll learn, there are many ways to move elements around on the web page. New methods have been developed over the years, and older things have fallen out of style. Flexbox was not always available in CSS. Its debut was revolutionary. Learn more about the history of Flexboxes. Many resources put it near the end of their curriculum because it is somewhat new as a technology, but at this point it has become the default way of positioning elements. Flexbox will be one of the most useful tools in your toolbox, so why not learn it first? That's what I agree with. I definitely know that I haven't really spent that much time on Flexboxes and understanding it, but I've used it a lot. Wesboss CSS Grid in the early 2018 found here today has been a buzz with reviews and enthusiastic. This has led to the few developers commencing comparisons between Flex and Grid layouts due to some of their similarities. But with this comes question, should I really learn Grid since I already know Flex? So my short answer to this question is yes, and if you want, you can stop reading now. However, it would be beneficial to get a few reasons why this is. So however, before we go into these, it is important to lay a few foundations like the history of how these layouts came into existence. Let's just have a quick look. Okay, that's not even far. It's not even that much reading. Okay, so this article is a summary of 2 articles I researched on. They can be summarized as follows. The Flexbox layout used today is very different what was first proposed. There's some grammatical issues here, but it's alright. The CSS workshop group has proposed the idea of a Flex layout in 2008, publishing the first working draft in 2009. This original specification was based on XUL technology used by Firefox to produce UI designs. Fortunately, according to Tab Atkins Jr., who is often referred to as the main author of the Flex layout and Grid layout, said this was woefully underspecified. The layout algorithm was slow, and between the 2 implementations, WebKit and Firefox, there were loads of divergent details. It also worked different across both implementations. In 2011, Atkins came in and rewrote the whole specification of Flexbox. The main goal of this was to try and remove the dependencies on all crazy float table, inline block, etc. hacks that he had to master as a web developer, something that a lot of front-end developers had become accustomed to, with better browser support. The 2012 version of the Firefox spec was put into W3C candidate recommendation. When a spec is a candidate recommendation, it is a certain point in the spec's lifetime. It is at a certain point in the spec's lifetime in the W3C. This means the spec is stable, supported in browsers, tests are being written for it, and there should be no significant change from this version. In 2013, Atkins rewrote an editor's draft in 2013. Whoever wrote this didn't read over it twice. To accommodate some new specifications, the new version of the spec made it better factoring of Flexbox's ability, tightened the algorithm, increased Firefox's efficiency. For CSS Grid, this was actually initially introduced by Microsoft with a proposal they submitted to the CSS Working Group. CSS Working Group? According to Dr. Bert Boss, who co-created CSS with Hakon William Lee, who also sat on the working group, grid-based layouts have actually been on his mind for quite some time, even before the draft. However, they were deemed too complex to implement. This, however, did not stop both creators bringing out some preliminary efforts, but none of these ever got shipped to any browser despite enthusiasm for their offerings. Advanced Layout Module 2005, which later became Template Layout Module. With grid concepts being thrown at the foot of the CSS working group with some regularity, folks were hopeful one of them would stick eventually. Fortunately, one of them did with the candidate recommendation implementation in 2016, with Tab Atkins Jr. being the main author. Well, okay. I'm not surprised if Benny Ogden is like an older guy. Okay, anyway. Many resources put it near the end of their curriculum, right? So you will learn how to position elements using Flexbox. You will learn about flex containers and flex items. You will learn how to create useful components and layouts that go beyond just stacking and centering. Okay, Flexbox layouts can get a little complicated. In a previous lesson, you learned how to inspect and debug things using your browser's dev tools. Those tools will be crucial for you in the following lessons. If something isn't behaving the way you expect, inspect it. In the developer tools should be your first step every time. Flexbox isn't necessarily any more difficult than any other concepts that we've covered so far, but it does have a few more moving parts. It is going to be somewhat difficult to make use of any of the things you're learning in these first sessions until you get to the end and can put it all together. As we go, do yourself a favor and play with all of the code examples. You will almost definitely need to come back and reference these lessons, or a couple of the resources we share with you, when you get the assignment at the end of the section. But if you take your time and experiment with all the code examples we provide, you'll know better where to look when time comes. Let's flex. Flexbox is a way to arrange items into rows or columns. These items will flex, grow or shrink based on some rules that you can define. To get started, let's look at a demonstration. We embedded a lot of interactive examples in these lessons. Take your time to experiment with them as you go through to cement the concepts in your mind. So you got a flex container, 1, 2, 3. Before I continue though, whoopsies. Flex tailwind is what I want to search up and just have a look. So flex auto, flex initial, flex. It's just flex. Where does flex container come in? You know? Maybe it's just this. Alright, well. Maybe I'm looking a little too far ahead, which is fine. And yeah, is this flex container, display flex. Okay, yeah, flex container is just, oh yeah, it's the CSS class. It's just a CSS class. It's just a selector. Yeah, it's just a selector. 1, 2, 3 result. Sure. So we'll get into exactly what's going on here soon enough. We don't have flex at all, but you're telling me I should comment this out. Comment it back in, maybe. Flex of 1. Oh, right. Okay, well, flex 1. Wait. Was that? Just refresh. Interesting. Comments prevent the browser from interpreting lines of code. All three divs should now be arranged horizontally. If you resize the results frame with 1x, 0.5x, and 0.25x buttons, you'll also see the divs with flex. The divs will flex. They will fill the available area and will each have equal width. If you add another div to the HTML inside, it will show up alongside the others and everything will flex to fit within the available area. Well, these are class 1, 2, 3. Doesn't matter, I guess, right? Sure, yes it does. It's hard to see what's going on in a small embedded CodePen. Feel free to edit on CodePen, fork on CodePen button. This will bring the example in a full-sized environment. Some of the later examples might especially benefit from doing this. Flex containers and flex items. Okay. Let's have a think, right? As you've seen, Flexbox is not just a single CSS property, but a whole toolbox of properties that you can use to put things where you need them. Some of the properties belong on the flex container, while some of the flex items. This is an important concept. The flex container is any element that has display flex on it. Really? That's true, isn't it? A flex container just has display flex. A flex item is any element that lives directly inside of a flex container. Wow. Makes sense. So if I have something like this, flex 1, none. Well, it's actually a display, right? So it's a display flex. So display flex will have to be looked into a little further as well. Let's see, display flex tailwind. I'm just going to the same thing. Maybe I go L. Yeah, so that's where I'm so block inline inline flex table, inline table caption. What else do we have here? Grid. Yeah, the other thing is I need to learn about grids as well. Except, let's have a quick look. Where would the grids be? Damn, we don't talk about grids here. That is definitely something else that I want to learn about. So I'm going to guess this grid understanding is back in intermediate HTML and CSS potentially, or advanced HTML and CSS. Introduction, Emmet SVG, default styles, CSS units, more text styles, advanced selectors, positioning CSS functions, form basics, form validation, intro to grid. Wow, you're really making me go through a whole lot to get to there. But maybe that's fine, you know. Maybe I'm fine with that. And so you got JavaScript as well as next. lesson, a bit of computer science, intermediate Git, working with remotes, a deeper look at Git, using Git in the real world, advanced HTML and CSS, transforms, transitions, keyframes. Honestly, this would be pretty useful information as well. Responsive designs, sure. And then this is where we can go into React as well, further. And databases, Node.js, okay, sure, databases. Oh, these are new. Sure. Node.js. Intro to backend, intro to frameworks. What is Node.js? Oh yeah, they changed the Node course recently. And getting hired. Well, imagine, man, full stack JavaScript, full stack Ruby on Rails, intermediate HTML and CSS again, databases, Ruby on Rails, advanced HTML and CSS, JavaScript, React, getting hired. But you're talking about Ruby on Rails, I'm guessing that's a backend? You know what I mean? But fair enough, you know, these courses seem pretty foundational and good in general. And okay, let's continue off from Flexboxes here. You know, I feel like I'm getting through it and I kind of get the big picture. Slowly. Let's have a think. Alright, so we're going to have to read through all of this. So flex and flex items. Okay, flex containers and flex items. As you have seen, Flexbox is not just a single CSS property, but a whole toolbox of properties that you can use to put things where you need them. Some of these properties belong to the flex container, while some go to the flex items. Okay, Flexbox is not just a single CSS property, but a whole toolbox of properties. Some of these properties belong to the flex container, while some go to flex items. A flex container is an element that has display flex on it. A flex item is an element that lives directly inside of a flex container. Fair enough. Okay, and you got a container with display flex and a item with height, border, flex, margin. So flex of 1. Somewhat confusingly, any element can be both a flex container and a flex item. Said another way, you can also put display flex on an item and then use flex boxes to arrange its children. Fair enough. Creating and nesting multiple flex containers and items is the primary way we will be building up complex layouts. The following image was achieved using only Flexbox to arrange, size, and place the various elements. Flexbox is a very powerful tool. So is this all? Oh no, this is an image. This is an image. I was going to say, if that's all, it would be epic if they just put HTML and CSS here, you know, for a course about HTML and CSS. Okay, the following questions are an opportunity to reflect on the key concepts. What is the difference between a flex container and a flex item? Well, a flex item is within a container, and a container has a display flex property, and a flex item has a flex 1. Don't know what that means yet, but I mean, I'm not too far from getting an understanding of what it means. Look, here's what I'm guessing, right? 1 and 1, maybe the top and the right, or the vertical and the horizontal. This is my guess. And then 0 being a width. Okay, we'll see. Okay. So how do you create a flex item? You put flex 1 on there, right? You put it in the children as well. Okay. E. AE. Oh, wait. Let's go back here. So, Interneting is Hard has a tutorial on modern CSS layouts with Flexbox. It isn't required. Possibly. Okay, well, I'm going to quickly see this. This might be pretty good, but there's a lot of reading. I'll keep it open. Alright, I'll keep it open. Consider. H. Whoops. Alright. How long would this be? Damn. Alright, so this will be another time. But it'll help me understand the differences in the 3 values. Yeah, what are the 3 values defined in the shorthand? And what are the 3 values for the flex shorthand? Alright. Cool. We're gonna pause this now. And we're gonna go to some actual study for uni. So yeah, so let's see. Let's save these contents. Let's save these pages. Okay. I'm good. Oh, okay. Well, that closes everything. Okay. I think I just crashed. Okay. I'm gonna take a quick break. It's 12 now. I might go to the gym. We'll see in a moment. I need to go to the gym though, and then take a shower, and then I'll be back. But oh, Duck Min, hi again. Hello. You're catching me at a time where I'm about to leave the PC again. Maybe. Let me think this through. So I'm gonna do some study for the rest of the day. That's the main objective. And with that, it means I need to do a little bit of a few things. I just gotta write this down somewhere, so maybe I'll just open up a daily note. That sucks, lol. Yeah, let's hope I don't let's hope I don't actually leave this for the next hour, because I might be able to do some stuff here first. So there are a few things. I have written it down. already on the side, but so finish reading. You from cybersecurity to partnership. TT. Hello TT again. I don't know what you mean by you from cybersecurity to partnership, unfortunately. Search algorithms lecture. An optional thing is to read chapter 1 of AI, a modern approach. So this is optional, which I might just stick it with a few new lines. And let's see. Another one down here was to read model-free, model-based PDF up to end of section 5. So those were those, but then we have CV. So CV, we have lecture 1. And before that, I wanted to read the actual lecture. So CV, lecture. So read CV lecture. I'll just call it CV, read lectures 1 and 2, and do lecture CV lecture 1. So that's for computer vision, and then API already considered. CS is okay. CS, New Directions in Cryptography, is a article that I could read as well. So CS, New Directions in Cryptography, that's something I could read. This is also APA. Today I want to know something, anything. Sounds good. Well, just stay tuned, I guess. I already spent some time earlier this morning on some Leetcode problems, if you want to backtrack a bit, and also on Flexboxes. So yeah. But right now, this will be like more specific to my study now, from here on out. Today, at least. Let's see what else. Yeah, there was some other CS stuff that I put in the actual page here. So I need to process. So CS process leftovers in cryptography and security. And we have one other subject that I just haven't had a start on yet at all, which is SML, statistical machine learning in there was a lecture 1 that happened yesterday that I couldn't attend, and I just got to watch that. But in the process, you know, I need to also understand the SML. That's a lot to do. Yeah. It's a bit. That's yeah, so it literally might take up the rest of today. But let's see, SML, I wanted to at least read lecture 1 before doing lecture 1, right? And now let's order these. So this was APA, AI Planning for Autonomy. That's one of my subjects. So I've got 4 different subjects here, right? But the thing is, I'm going to end up removing one of these just to pick which one I like the most. You know, at the end of the day, one of them has to be cold, and this is only the first weekend. And once I've solidified which one to be cold, I can hone in on the other 3, and then do the cold one next semester or next year. That's the plan, at least. And you know, I'm doing this to explore basically the different subjects. Alright, so APA, finish reading search algorithms lecture. That shouldn't take too long. Then I can read CV before doing the lecture. Okay, and then I can process the leftovers last, I reckon. I think that's fine. And these are optional to read and do if I really need to. Okay, so I'm thinking, you know, this takes about 30 minutes, right? 30-minute problem, task. Now, also, by the way, this is like literally what right now, like the task manager that I'm thinking of building, the scheduler that I'm thinking of building, aims to solve this problem that I have of having tasks that I want to do, and me putting down certain like limited time periods, and slapping that onto like a calendar. So I mean, if this is you know, this is what motivates me to build this app, to automatically schedule tasks and see it in calendar view. So, you know, having some calendar and having some task section, add your tasks here, it gets shown directly on here. But, you know, there's a lot to do still here, but I wish I had that functionality already. You know, I wish I had the skills already to build something out like this. And, you know, this is going to take some time, so it's not going to happen overnight, or like even within the next 3 months. I'm thinking this will be like a year's worth of work to do well, you know. So we'll get there, but for now I have to cope with manually typing some of these. So CV read lectures 1 and 2, I'm going to say that takes 45-ish minutes. CV lecture 1 has to take 1 hour. SML has to take I'm going to say 15 minutes, maybe 20 minutes. And then SML lecture 1 is taking an hour as well. And then the leftovers, this will take 1 hour. Okay, so the total time that I'll be spending is roughly, I mean, looking at this, it's almost 5 hours. So 4.5 hours roughly. Maybe a little less. Okay, but can I do this in the rest of the time that I have today? You know, doing some mental math here. Say I start at 2 after I've had lunch and gym, and lunch, gym, shower. So I might go to gym now, have a shower, gym now, come back to have lunch, and then take a shower, and then be back before 1:30 maybe, or 2 might be better, and then continue off there with the rest until 6 p.m. It's doable, and I think I'll be fresher that after a shower. So I think that's what I'll do, you know. As such though, you know, I could spend a little bit of time just reading over this before I go. Yeah, but no, it'll mess up the other the plan. Okay. Should I go now? Question is. Let's have a look. It has been an hour and a half and a little bit more, which to me feels, yes, I should take a break, because I feel like that was some solid learning. Alright, yep, that's what I'll do, I think. So plan is I'll be right back. I'll be back at around 2 p.m, which is an hour and 50 or so minutes from now. And hopefully, you know, I'll be more fresher as well, because I actually didn't sleep all that well last night as well. So alright, we'll keep it as is for now, and I'll be back in 2 hours. Alright. Bye, Duckman. Have fun. time for me to just silently work here. So I'm gonna stop the music. Thanks for the follow. Ari Coleman, thanks for the follow, man. TT. I'm watching a lecture. This is image generation, generating faces, but it's the intro lecture to computer vision. Hello, random guy. Hello again. What's Odin Project? That is a course that I'm taking online that's free, and it's a collection of, information on web development specifically. So if you search the Odin Project, they have different courses. They got a foundations course, which is just on HTML, CSS, and JavaScript. And I'm, about 2/3 of the way through now. But there's also other courses after that, after the foundations, that gives you a wider perspective on full stack development, JavaScript, for example. And I did some work here already today. So the main focus for tonight is my actual study for uni. So going to be focused on that mainly. But once I've completed all those, that is most of these tasks, I'm definitely actually going to go back to this. That's if I have the time to. So yeah. And yeah. Which framework for backend? I guess for me, the thing that I'm using right now is Fast API, which is purely in Python. I believe that full stack JavaScript and full stack Ruby on Rails. If I'm not mistaken, Ruby on Rails here is used as a backend. JavaScript is used as also the backend as well. Yeah, in these two at least, I think. And but I'm using something completely different. And the main objective for me is to learn about front-end stuff from the Odin project. Just because that's just my main concern at the moment. But yeah. Thanks for the sub, Nico. Bernoulli binomial, multinomial, Poisson. Govern real value taking discrete values. Described by probability mass density. Mass function, px. Oh. NG says, is that Zettelkasten? Yes, it is. If you're talking about my Obsidian layout, yeah, it's a little bit messy because a lot of things are in inbox right now. But yes, I got fleeting notes, reference notes, literature notes, and permanent notes. Yes, I am following Zettelkasten. Great. Have a productive day. All good. Expectation. Ooh, Ichiro. What's up, David? I see you are studying. Good luck with that. Thank you. Deciding on which subjects to drop, actually, as well, eventually. Seeing the formulas makes me remember why I don't miss uni. Yeah, that's true. That's true. I'm looking at some of these and just keeping a tab on some of the concepts: probability, mass function, density function, expected value. I'm not even sure if I properly remember each of these yet well enough to say what they are. But I'm sure if I see enough examples, I'll go through it with it, okay? But yeah. Not something very pleasing to watch, I know. I remember when I was studying neural networks, man, it was so hard to even grasp the concepts because the concepts for the class was all convoluted. I used to say every class, give me something that is not a formula. Yeah, that's right. I mean, if I do continue with this subject, it's I'm gonna heavily cope with doing practice problems. And then looking at solutions before I even finish the problem properly. Just like what I do with Leetcode nowadays. See the solution before solving the problem. But still understand the problem, right? Right. Right. Right, haha. Well, I'm gonna be here for a while, but I'll stop interrupting. All good, man. All good. Yeah, okay. Before I continue, I'm going to reevaluate my life for a second. I don't have it here. I'm going to just have to write it here. My course planner, okay. Restore from. That's not what I want to do. Let's just create a new tab. Got you, I do the same every day. Yeah, man. Just gotta reevaluate my options, man. What is it? Yeah. Unity meld planning. So I have some plans. I did intro to ML. I can choose to do any one of these. Problem is I've already done models of computation. I've done declarative programming. I've done cryptography and I'm doing cryptography and security. And I could do advanced database systems or statistical machine learning or this subject. Reevaluate if I should keep study or I replay Elden Ring again. Yeah, replay. For the 5th time. Okay, right, so statistical machine learning or advanced database systems. You know, pick my poison. Or digital impacts on business and society. Replay is a better option always. I don't disagree. Problem is when you end up replaying a subject. Uh-oh. Well, you just went through that specific page too fast, okay? Throughout the subject, we'll often encounter norms that are functions where the real nth dimension maps to the real dimension, which is, I'm guessing, just R1 of a particular form. Intuitively, norms measure lengths of vectors in some sense. Often component of objects or stopping criteria in optimization for ML. More specifically, we'll often use the L2 norm. Okay. And so the L1 norm, absolute norm, or Manhattan distance. Wow. But it's sophisticated. Vector spaces and bases. Okay, fair enough. Yep. Hello, Alahan. What's up? I'm studying. Contemplating whether I should take this subject. Alright, so for a formal definition of vector spaces, yeah, okay, fair enough. Any linear combination that of vectors is an element of V some vector space. Is a new vector for some scalars a to k. A set of vectors is called linearly independent if one can be written as a linear combination. If one element can be written as a linear combination of the other elements. Set isn't linearly dependent if it's linearly independent. Yeah, I remember this. But let me continue. Hmm. So this guy just said, our lecturer just said, do not worry about the maths, because he's just pulling this out just to remind you. But damn, he's already probably made half the people in this subject fear. It says, I would feel like I am so dumb, so you have to tell me this. Wait. Yeah. Let me think. I mean, the thing is, sometimes, when you're told of something that's obvious, it makes you second guess yourself as well. Sequences and limits. At least I feel somewhat okay with these. Supremum. Damn. Least upper bound is called supremum. Least upper bound. Real analysis for reals. Oh wait, you've written a few things. What is this? Ichiro says, off topic, I'm trying to build and dockerize a Java project on an AWS EC2 instance, and it crashes the whole VM. Wait, okay, let me reprocess that in my head. So you're trying to build a dockerized Java project on an AWS EC2 instance. Fair enough. And it crashes the whole VM. Maybe you just don't have enough RAM, right? I could never be DevOps. Damn, how the hell do people make build pipelines on servers with 256 megabytes? How? I mean, are you... Who are you getting this information from to get 256 megabytes in the build pipelines? I have like 2 gigabytes in the build pipeline of the scheduler app, but I feel like Java projects could get pretty big just from the packages and the jar files, .jar files. Actually, I don't know that much about how Java packages work, but yeah. I have always told you my fucking English. I have always told that you need decent machine to make productive builds, but I have always received comments from DevOps saying things like, I only need the most basic resources. I also refuse to believe. It's just that I don't want to pay for the VM, haha. Ah, yeah. Hey, I'll tell you what. Okay. Well, okay. I think when people tell you about having the basic resources, there's a big asterisk on that, in the sense that 2 gigabytes is probably the minimum that they're thinking. You know what I mean? And when you're looking at AWS and the 256 megabyte is the highest option before you have to pay, they're doing that for a reason. You probably can't DevOps with 250 megabytes of RAM. And I would suggest, as a alternative to AWS, is so this is an AWS EC2 instance. If I'm not mistaken, EC2s are just like it's like you get a Linux VM, right? So if that's the case, search up Oracle Cloud free tier. They have a generous free tier. I have 1 GB of RAM, still kind of, yeah. I mean, I still think 2 gigabytes has to be at a minimum. Because what is it that I have here? You know, they have ARM computes. I'm not sure if that'll work with your x86 Java and whatnot. I don't know if it's if you have Java on an x86 machine actually. Maybe T2 Micro is ARM or x86. I forget. But look, there is a 1 gigabyte memory x86 as well. And there's also ARM based, but you have 24 gigabytes of memory. And I'm using this ARM based compute for the scheduler app. So if I go there, like, I can show you what how that's kind of set up. I mean, this is, you know, this is the app and all, but you know, in the build, you know, I'm deploying to staging, and let's see if there's a way to actually see what server is being contacted. Basically, like, all the commands that you see that are run here are like on the specific Oracle Cloud instance that I set up. But if I go to settings, I'll be able to find it. Runners, right, it's called runners. So yeah, you see I have 2 runners here. I believe this, you know, I had a Google Cloud runner. That one was an x86. Well, this is x64, but you know, I think this is just x86. And this one is like 1 gigabyte, and it couldn't do it for me either. But this one is from Oracle Cloud. This is the ARM64, and it's also, I forgot, I think it's 2 gigabytes of RAM, and that then works for me. Yeah. And you know, you can connect your runners here. New self-hosted runner, if you want that way. And then you just need to look into how to actually use runners. I mean, I got this idea from the actual template that I got this whole project from. So yeah. Okay. Regardless. Sequences, limits and sequences. Okay. I'll try the Oracle Cloud VM. Sounds cool. I actually was able to get the thing working, but I had to free resources before starting the build. Yeah, fair enough. Is kind of a boomer. Do you mean boomer as in bummer, or as in you're a boomer? In any case. Yeah. Boo, it sucks. Yeah. Alright, that's it. At this point, you'll just buy a Raspberry Pi. Honestly, it could be a good investment. Not gonna lie. Personally, you know, I have a Raspberry Pi, so there's a bias there. And yeah, you know, I have a full home server set up as well. So I'm kind of also deep into a self-hosted ecosystem. And I've kind of looked quite deeply into all the Raspberry Pi stuff, you know. Like if you look at the computer behind me right now, this one right here, this is also another computer, server, that's on 24/7. So it's not even like a desktop machine. There's like 5 different drives in here, which is like 30 terabytes of storage. So it's our home NAS basically, among other things, because it's got some other services running on it as well, albeit quite slowly. And then yeah, the Raspberry Pi, I use it for like network stuff. So like something called the Pi hole. I use it for the Pi hole, which is just a network ad blocker. so you can see all the different I guess domains that have been active, but also, you know, a few of the blocked activities or blocked queries, which are all like ads, you know. Although I don't think this is just client activity. Oh yeah, but these are the things that are blocked. I'm seriously thinking of buying a Pi just because of the Pi hole. Yeah. See, I'm guessing you've heard of Pi hole then, and everything else that comes with it. Yep. It's good if you want to get started learning honestly about like just like server management, you know. I think the Pi hole was the first thing that I got into when I got the Pi, and then it just snowballed from there. I just started like learning about everything from like r/self-hosted on Reddit, which is just all self-hosted versions of you know, apps, services that you want to have. You know, for example, you know, there's GitHub, right? Everyone knows GitHub, everyone has GitHub. But now I have Git, which is on my own local network under my domain name, but on my local network, right? So if you try to go to this domain, you actually wouldn't be able to visit it because it's under my subdomain local. And then, you know, I got my single repository in here, which is my Obsidian. I have my servers too, but they are kind of a mess because I like to build my infra by hand. I don't use many tools. I don't know. Man, I mean, to be honest, that might be, you know, you might learn more doing it that way. But surely we use Docker. Surely. Surely. Yeah, at least Docker. I personally have like a folder with all my Docker containers or all my Docker specifications, I guess. You know, you got Docker Compose. So I got Docker Compose, and then, you know, it's in its own file for each of the stacks that I want to build up. But the thing is, I don't want to just rely on Docker now. I want to also start using Kubernetes. So the next time I change things up, I'm going to be using Kubernetes. And I think, you know, using Kubernetes just means a little bit of more, it's a bit of an abstraction, but it'll probably also save resources when it needs to save resources. And it'll scale, so they say. And then there's also Image, which is another good app that I self-host. I want to learn K8s too, man. I don't find the time. Yeah. I only found the time because I did a subject last semester called Cluster and Cloud Computing, and that went through Kubernetes to some extent. And yeah, I mean, that's just how I learned it that way. But yeah, I mean, even with K8s, I feel like, you know, all you need to do to get started is just search up Google Kubernetes. what is Kubernetes? And then surely they have a course here. Well, maybe I should just search Kubernetes. Training. Intro to Kubernetes. Is this paid? Free. But there is an optional upgrade. I bet the optional upgrade means that's where you get the certificate. Possibly. Introduction to Linux. Introduction to Cloud Infrastructure Technologies. Yeah, man. Whenever I see a course, I know that I'll never end it. That's also, yeah. You know, it happens to me too. Yeah, good, actually, you know, okay, you say to prefer to read all the docs. I agree with that. I actually do agree with reading all the docs. Sometimes you can lose, I guess, your motivation in a course just because, you know, it's a structured something and you know, you just want to do other things sometimes when you're just like in the motions of things. But you know, going to the docs when you need it, that's pretty OP too. I'm actually thinking like, I think, right, I don't know if there is, but I think there are a lot more engineers out there, or developers, who don't read enough of the docs. That's my personal belief, at least from the people that I've had experience with, or had the experience to talk to through like startups that I've done in the past. That startup is now in like a startup accelerator, but I'm not sure how well it will go, I suppose. But yeah. People tend to prefer videos, but I don't. I feel like they don't teach you anything. Yeah. I suppose it depends on what type of course it is, right? I mean, I'm imagining you're thinking the courses are like video courses. Personally, you know, the courses that I'm thinking of, actually, I guess the only course that I've really been doing is the Odin Project, right? So I've been thinking about that one and how it's all just text-based, mainly. But yeah, I think, yeah, videos sometimes you can just gloss over things quite a bit. And you actually don't take it to heart unless you read it out yourself. I'm Savasco, hello again. Nice for you to join. I need to get better at slowing down when reading the docs. Too often I just want to read whatever is relevant to what I'm doing at the time. Yeah. Often I'm missing some context. Yeah. I mean, to be honest, would that be a bad thing though? You know, just getting what you need and then getting out. I guess if it means that you don't get a full holistic understanding and you're just doing it because they say to do it, then that's a problem. But, you know, like I would say, for me at least, learning about Flexboxes, as soon as I finish learning about it, I'll be able to write anything Flexbox related, and I'll continue back on my scheduler development. Because, you know, technically, you know, I've marked this myself as to get up to the end of Flexbox section in the Odin project before I can continue with any of these other things. That's the plan. Okay, SML homework 0. And there's something else. What was the other thing that I needed to do? So homework 0. I need to open that back up. SML. Let me see. Reference notes. Basics. Oh, no, this isn't even the page. Go back. Ah, yeah, here we go. Okay. Scroll down. Oh, yeah, it's the Jupyter Notebook setup. That was the second thing. Jupyter. What is it? So Iterative also says, I used to dislike the idea of reading books for technical matters, but after reading some about data engineering and software architecture, I started to love them. Oh, and a good book to get the explaining of a course and technical details of the docs. Oh wait, hold on. I think Mom was talking to me. Give me a second. Wait, okay. Let me finish what you said. So on a good book, you get the explaining of a course and the technical details of the docs. That's true. Data engineering and software architecture. Yeah. On a book, writers don't worry about the time they use to explain, because the reader has all the time of the world available to read it. True. So I recommend reading books. Yeah! Let's go! I think that's a good thing, too. That's true, though. That's very true. The thing is, you know, sometimes you're just limited by time for certain things. If you're doing a coursework, you're limited by time to reading that textbook of ideas or whatever, which is something that I think does throw me off at times, because it's like, you know, you have to finish a course by this deadline, you know, by the end of the semester, and they smash everything in lecture slides, but sometimes you're just left with no time to actually read the textbooks properly. And that's just something I think is a bit of a shame, because it really doesn't help foster anything. So what extension are you using for the side tab in Firefox? Yeah, it's what Sabasco says. Sideberry. It's pretty cool. You know, I can switch between tabs. My objective at some point in my life was to build my own Chrome extension, which is still true, I could. But I switched it up to this. Okay, let's see. So that is good. I've got to process some leftovers for this. Oh, if you're looking to spend more time configuring shit, you should look into a window manager like i3WM. Oh no, don't introduce me to it. Oh. Not again, window managers. Oh, and it's for X11. Interesting. Interesting. Maybe I will star that. Oh, true. Vim bindings. Imagine. Because right now I just use like default keys, right? What is it? Control. Bro, I don't even know what they are anymore on Windows. I know for a fact what they are on Mac and stuff, but not for Windows. That's what all addicts say about their addictions. Don't believe the propaganda. Hey, I'm pretty easy to influence, I won't lie. God damn. Oh man, this is gonna be another rabbit hole. I'll look into it. I'll look into it at some point. Alright, we'll leave it as is. But now it's in my radar. Wait, is it cross-platform? Okay. Okay. So I mean it's for yeah, it's for Linux machines, right? At least I don't need it. At least I can't need it for Windows. Yeah. I'm sure there's Windows alternatives. Man's ended up spending $600 on a keyboard. What's a few hours setting up a... I did put so many hours on tiling window managers, I ended up using Genome again. Damn. What didn't you like about them, Ichiro? Yeah, that's a good question. Also, is it Genome or GNOME? GNU. Maybe it is GNOME. Whoops. Makes sense. You just weren't doing anything else. I mean, that makes a lot of sense because I mean it's very relatable is what I'm saying. when you just customize something to no end. Man, it's just addicting. You know, at times I jailbroke my iPad, and for that whole semester in high school, I'm pretty sure I was out of it. Not really, but it was it did take up a lot of my time. You know, when you jailbreak an iPad, you're like, oh, there's so many things you can do. You buy like $2 features, right? That you buy from some place online, some dodgy website, and then you sideload it or boot it or whatever you call it onto the iPad. I was an iPad kid. Okay. Now let's process some leftovers. So, in the question of where to find the textbook, let's say we go to CS. Spent a few hours last week setting up the same key bindings on Linux and Mac. Damn. How do you find the time? How do you find the time? I'm Savasco. Oh, fuck. How do I undo? I can't undo that. Before it saves on my other device. It already saved on my other device. Yeah, you prioritize config when you really shouldn't. Hey, whatever makes you happy at the end of the day, like whatever makes you want to use your device more at the end of the day, I feel is kind of worth it, to be honest. Yeah, rising your Linux distro is an interesting way of burning time. Two ways of thinking. It's just two ways of thinking. You know, I relate to the both of you. I already did that. The week one quiz I can redo a little bit as well. Alright. Catch you later, I'm Savasco. No, I mean, I love it. It's just that I was always looking at other people's desktops and wanted to add the little details. Yeah. Masquerade non-repudiation. Okay. I can still redo the quiz, can't I? I can. I'm guessing it's not marked at all then. All good. All good, Ichiro. Let me study. Nah, good break, I'd say. Intro to numbers, intro to cryptography, I think, is what I need. And I need to write basic security services. Each one of these I need to understand to its entirety. Authentication, confidentiality, integrity, source authentication, and network QoS. Sure. I mean, just looking at that makes sense as is, so I don't think I need to write anything there. Authentication, confidentiality, integrity, non-repudiation, and availability. Like, let's see, how will I explain these, right? Authentication, confidentiality, integrity. Non-repudiation is the main one though. Is the property of agreeing to adhere to an obligation. More specifically, it's the inability to refute responsibility. For example, if you take a pen and sign a legal contract, your signature is a non-repudiation device. So you're obliged. Wait, in law, non-repudiation is a situation where a statement's author cannot successfully dispute its authorship or the validity of an associated contract. Which makes sense in the sense that it's basically saying the author can't deny what they've said or done or written. How does that relate to cryptography? Non-repudiation is the ability to prevent an electronic message or transaction that someone cannot deny the validity of something. It is a legal concept that mostly used in information security and refers to a service which provides a reason for the origin and integrity of data. In other words, non-repudiation makes it very challenging to strongly deny who, where a message comes from, as well as the authenticity and integrity of that message. So it makes it very challenging to strongly deny who or where the message comes from. Man, I gotta save this. Let me sync my articles. Explain non-repudiation. And then this is where I link to what is non-repudiation. Tab, tab, or do I go down? Up. Okay. Damn. Sure. Say I'm good here. Shivam Purohit. Shivam Purohit. Nice to meet you, man. Thanks for joining. Okay, so basic security services, security threats in the network model. Just knowing all of these exist, I think, is fine by me. Yeah, William Stalling's book is another thing that I'm worried about not having. I don't need this anymore. He's got a Discord server, cheeky little Discord server. Setting up MySQL, installing MySQL. Oh man, the pain of this subject. Group work. Okay, well that's not the subject anyway that I care about. Assignment 1. The placeholder will contain fact information about assignment 1 when it's released. Okay. I was like, if it's out already first week in, my gosh. Please share your own test cases for assignment 1 in the comments. Please do not share your code. Please provide a pair of XXX test and solution files. Please like the comments if you tried the shared test cases and succeeded. Damn. Sharing is caring. Not gonna lie, I'll like that. Kian D'Souza. I'm looking for teammates for the group research project. I have a H1 RAM and really want to do well in this subject. If you're also aiming to do well and would like to team up, shoot me an email. Maybe. Well. You've asked a very good question, Sir Anonymous. I probably can't show it on stream. But libgen, basically, is all I can say. Surely. Where is the 7th edition? Seventh edition? Well, I found the 7th edition. Non-repudiation. Alright. So William Stallings, I've downloaded that now. That's literally nothing. So let me clear some of these then. I figured out where to get the textbook. Okay. Now I need to understand the well-ordering principle in terms of the division theorem. So, where is the division theorem? I'm also trying to remember one thing from one of my tutorials that I just had yesterday. It was like a pretty cool concept on how to solve a particular modulo problem. How to find the greatest common divisor of n squared and n plus 1, where basically you do the normal division or you do a factorization to find some remainder. That remainder turns out to be 1. So then the problem reduces down to n and 1, or n plus 1 and 1. A little iffy on the details. Bring it up here, actually. Ooh, 5%. When is this going dead? It's alright. I'll, let me get my charger. Okay. The idea was that n squared . n minus n plus 1, n squared divided by n plus 1. Nope, 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 nope. Yes, okay. Now this becomes n squared plus n minus, to get minus n. Minus 1 then is minus n minus 1, which gets plus 1. So the remainder is 1. So GCD of n and 1. That's fine. No, 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 no. N plus 1. And the mod. N plus 1 and 1. Something's off. Re-evaluation needed later. Alright, now it only goes to the world ordering principle. This is from brilliant.org. Okay, division theorem. Proof. Proof wiki. Sussy that it takes a bit of time to load. But it loads, okay. Yikes. I gotta eat soon. Is 6:20 already? Damn. Days gone by. Okay, but I got the textbook. Right, so this is what I want to download. Save. I'm gonna save this in here. Resources. Okay, if you lose some marks in your individual, the bonus marks can help you gain some marks back. The total individual assignment marks will not exceed 15. Alright. I will just... Where's the textbook of the subject? They're available now, sure. Yeah, this is a good subject that I'm actually going to be invested in, so I'm still going to have to look at this properly. Whoops, I just closed this single tab that I need. Okay. Workshop setup. Ugh. I might browse over these certain documents just because why not, but I also need to do some workshop setups. Possibly not tonight, my thinking is, but SML homework 0 I want to try. So I'm going to say that goes here. And I'm going to browse through each and every one of these. And alright, the thing is I gotta eat dinner like in a minute, but what I will do is I know I gotta do each of these. I'll do this and the next one. Tomorrow. CS, new directions in cryptography, homework 0. So this will finish off the night, I reckon. But, you know, if I have the time, I'll do one more section of Flexboxes of the Odin Project. So that's the plan for tonight, for the rest of the night. And now I'm going to just eat and I'll be back. Okay. Putting on some music. Thanks, Ichiro. Oh, Ichiro's gone. Oh, good. Dude, I'm gonna DC now. I've go to sleep because I got work tomorrow. Hopefully I can hop in soon. Good luck with studying the scheduler. See ya. Oh, good. Oh, good. Man, just gotta sleep. Gotta finish watching a video first. Okay, actually, I just realized nobody could hear me. I'm just saying how brain rot this is. Oh my god. What in the world? Like, sure. What? What? Nah, this is so dumb. That's on YouTube, by the way. Okay, normal cam. It's quite a lot. Just gonna check on what I gotta do tomorrow. Tomorrow I have a few things. So there's a lecture at 11. There's another lecture at 12. And then 3-hour-ish break until 5 p.m. where there's one more lecture. Second lecture. Okay. So, you know, what I'm going to do right now is quickly browse over some of these. So that I can tick them off. Potentially. Okay, maybe this might be better. Alright, SML, homework 0. Just to quickly have a check. So is this, yep, this is it. SML. Mm-hmm. I'm gonna, let's see. Move these back. I'll move this to the side to charge. Okay. It's still kind of in my way, isn't it? It's kind of bad. Yeah, I'm alright with that. Okay. Grade scope. Could be an assignment actually. Not an assignment. Homework 0, here we go. Alright, we're gonna have to spend some time here as well. Nah, I don't want to do this tonight, so I'm gonna not do this tonight, but I have it downloaded, right? At least I know what it looks like. And actually I haven't downloaded it yet. Download to not CS to SML. Alright. And we're gonna close this. So homework 0 is something that I gotta do. Let's put it down further. Close that. Keep this open. APA read chapter 1 of AI, a modern approach. I could do this, and I might not do this, so we'll have a quick browse over what it looks like. AI, a modern approach, that's going to be in my folders. So APA, resources, love how there's 29 pages of this. We call ourselves Homo sapiens, man the wise, because our intelligence is so important to us. For thousands of years we have tried to understand how we think. That is, how a mere handful of matter can perceive, understand, predict and manipulate a world far larger and more complicated than itself. The field of artificial intelligence, or AI, goes further still. It attempts not just to understand, but also to build intelligent entities. AI is one of the newest fields in science and engineering. Work started in earnest soon after World War II, and the name itself was coined in 1956. Along with molecular biology, AI is regularly cited as the field I would most like to be in by scientists in other disciplines. A student in physics might reasonably feel that all the good ideas have already been taken by Galileo, Newton, Einstein and the rest. AI, on the other hand, still has openings for several full-time Einsteins and Edisons. AI currently encompasses a huge variety of subfields, ranging from general learning and perception to the specifics, such as playing chess, proving mathematical theorems, writing poetry, driving a car in a crowded street, and diagnosing diseases. AI is relevant to any intellectual task. It is truly a universal field. What is AI? We have claimed that AI is exciting, but have we not said that it is? In figure 1.1 we see 8 definitions of AI laid out along 2 dimensions. The definitions on top are concerned with thought processes and reasoning, whereas the ones on the bottom address behavior. The definitions of the left measure success in terms of fidelity and human performance, whereas the ones on the right measure against an ideal performance measure called rationality. A system is rational if it does the right thing. Given what it knows, historically all 4 approaches to AI have been followed. Each by different people with different methods, a human-centered approach must be in part an empirical science, involving observations and hypotheses about human behavior. A rationalist, I'm not suggesting that humans are necessarily irrational or the sense of emotionally unstable or insane. One merely need note that we are not perfect. Not all chess players are grandmasters, and unfortunately not everyone gets an A on the exam. Some systematic errors in human reasoning are catalogued by Kahneman et al. A rationalist approach involves a combination of mathematics and engineering. The various groups have both disparaged and helped each other. Let us look at the 4 approaches in more detail. Acting human, the Turing test approach. Thinking humanly, the cognitive model approach. Thinking rationally, the laws of thought approach. Acting rationally, the rational agent approach. The foundations of artificial intelligence. Damn. Computer engineering, control theory and cybernetics, linguistics, the history of AI, the gestation of AI, the birth of AI, early enthusiasm, great expectations, until there was a Cold War, the key to power, knowledge-based systems. AI becomes an industry. The return of neural networks. AI adopts the scientific method. The emergence of intelligent agents in 1995 to present. The availability of very large datasets. The state of AI art. And the summary. This chapter defines AI and establishes the cultural background against which it has developed. Some of the important points are as follows. Different people approach AI with different goals in mind. 2 important questions to ask are you concerned with things or behavior? Do you want to model humans or work with an ideal standard? In this book we adopt the view that intelligence is concerned mainly with rational action. Ideally, an intelligent agent takes the best possible action in a situation. We study the problem of building agents that are intelligent in this sense. Philosophers going back to 400 BC made AI conceivable by considering the ideas that the mind is in some ways like a machine, that it operates on knowledge encoded in some internal language, and that thought can be used to choose what actions to take. Mathematicians provided the tools to manipulate statements of logical certainty as well as uncertain probabilistic statements. They also set the groundwork for understanding computation and reasoning about algorithms. Economists formalized the problem of making decisions that maximize the expected outcome to the decision maker. Neuroscientists discovered some facts about how the brain works and the ways in which it is similar to and different from computers. Psychologists adopted the idea that humans and animals can be considered information processing machines. Linguists showed that language use fits this model. Computer engineers provided the ever more powerful machines that make AI applications possible. Control theory deals with designing devices that act optimally on the basis of feedback from the environment. Initially, the mathematical tools of control theory were quite different from AI, but the fields are coming closer together. The history of AI has the cycles of success, misplaced optimism, and resulting cutbacks in enthusiasm and funding. There have been cycles of introducing new creative approaches and systematically refining the best ones. AI has advanced more rapidly in the past decade because of greater use of the scientific method in experimenting with and comparing approaches. Recent progress in understanding the theoretical basis for intelligence has gone hand in hand with improvements in the capabilities of real systems. The subfields of AI have become more integrated, and AI has found common ground with other disciplines. Not bad. However, if I were to scroll up to introduction, yeah, I'm going to say that's fine. Model free, model based PDF up to the end of section 5. Now that's also in here. Okay, let's read this. It shouldn't be long anyway. During the 60s and 70s, AI researchers explored intuitions about intelligence by writing programs that displayed intelligent behavior. Many good ideas came out from this work, but programs written by hand were not robust or general. After the 80s, research increasingly shifted to the development of learners capable of inferring behavior and functions from experience and data, and solvers capable of tackling well-defined but intractable models like SAT, classical planning, Bayesian networks, and POM DPs. The learning approach has achieved considerable success but results in black boxes that do not have the flexibility, transparency, and generality of their model-based counterparts. Model-based approaches, on the other hand, require models and scalable algorithms. Model-free learners and model-based solvers have close parallels with System M1 and System 2 in current theories of the human mind. The first, a fast, opaque, and inflexible intuitive mind. The second, a slow, transparent, inflexible, analytical mind. In this paper, I review developments in AI and draw on these theories to discuss the gap between model-free learners and model-based solvers, a gap that needs to be bridged in order to have intelligent systems that are robust in general. 2018. Yeah, okay. problem of generality. Okay, I'm fine. All right. Control Shift T. Keep that open for now. New Directions in Cryptography by Diffie-Hellman. By Diffie and Hellman. We'll keep that. I'm fine with just not looking at that for now. Maybe in future. But you know, I really want to do the Odin project at the moment. Advanced students read section 2.1 to 2.4. Read chapter 1 of textbook. So these things that I've listed, I might just do tomorrow. Homework 0, yeah, I said I'll do that tomorrow. And the Odin project. I'm going to finish off with the Odin project tonight as well. And yeah, we'll be good for now. So let's close some of these tabs. Whoops, that closes everything. Here we go. Growing and shrinking. We can close this for now, close these two, and open up this sidebar here where we got all our changes for today. Oh, we got a frozen screen. A frozen app. That is a frozen app right there. Let's hope that I can open that up again with no issues. Wonder what would happen. Let me delete this. Let me click on this again. Is it gonna, yeah, it did the same thing, it crashed. it's unresponsive. So I know not to open it through there. But I have this that I can open. I have this that I can open. Non-repudiation. They both. Data.json and types.json. I am fine with committing it all. Okay, let's commit it all. Close Obsidian and reopen it. Unfortunately, this is what we have to resort to. Just commit the files. And now we can focus on okay. Let's have a look. We're going to go through this growing and shrinking. And then after I go through this, you know, hopefully it doesn't take a full hour to complete, but if it does, we'll have to call it a night because it'll be 9 by then. But yeah, let's see. I'd like to just think. Tomorrow, I'll have to get to uni by 11. Which means I have to leave home quite early in the morning. And that'll be fine by me. Alright, let's go. Let's do this. So growing and shrinking. Let's look a little closer at what actually happens when you use Flex 1 on those Flex items in the last session. You will learn the 3 properties that are defined by the Flex shorthand and how to use them individually. The Flex shorthand. The Flex declaration is actually a shorthand for 3 properties that you can set on a Flex item. These properties affect how Flex items size themselves within their container. You've seen some shorthand properties before, but we haven't officially defined them yet. Shorthand properties are CSS properties that let you set the values of multiple other CSS properties simultaneously. Using a shorthand property, you can write more concise and often more readable style sheets, saving time and energy. In this case, flex is actually a shorthand for flex, grow, shrink. And flex basis. Grow, shrink, and flex basis. In the above screenshot, flex 1 equates to flex grow 1, flex shrink 1, flex basis 0. Very often you see the flex shorthand defined with only one value. In this case, that value is applied to flex grow. So when we applied flex on our divs, we usually actually specified a shorthand of flex 110. Interesting. That is very interesting. Alright. Now what does this mean? Flex grow expects a single number as its value, and the number is used as the flex item's growth factor. We applied flex 1 to every div outside our container. We're telling every div to grow the same amount. The result of this is that every div ends up the exact same size. If we instead added 2 to just one of the divs, then the div would grow by 2x of the size of the others. The flex shorthand has the value flex shrink and flex basis. Is 210, 110. When you're just not 2. Okay. So you're telling me that without these two values, it would still be the same. Well, the obvious question becomes, what if you add just this? Okay, flex shrink is similar to flex grow, but it's the shrink factor of a flex item. Flex shrink only ends up being applied if the size of all flex items is larger than their parent container. If our 3 divs from above has a width declaration of width 100 pix, and flex container was smaller than 300 pix, our divs would have to shrink to fit. Okay. I'm gonna stand up. Okay. I feel like doing monkey tap right now, man. I'll just do a little bit. Not bad. Very bittersweet. Ooh, is it not this value? What's a tilde symbol at? Oh. Sabodai walnuts. I haven't learnt a lot by writing my Linux. I haven't learned a lot by writing my Linux anyway. Yeah. Fair enough. Just wanted to give your own input there. Fair enough. Hello KFC, once again. welcome back. I'm just practicing touch typing, I guess. Yeah. And then, because my brain's a little spent now today, just doing some, I guess, less mentally demanding work. But then I'm going to continue with the Odin project here. After this last final session. Oh, your boy's slowed down a lot now. Damn, bro. Okay. Let me get back to this. Flex shrink is similar to flex grow, but it's just the shrink factor of a flex item. Flex shrink only ends up being applied if the size of all flex items is larger than their parent container. The size of all flex items is larger than their parent container. Fair enough. For example, if our 3 divs from above had a width declaration like width 100 and a flex container with smaller than 300 pixels, our divs would have to shrink to fit. The default shrink factor is 1, which means all elements will shrink evenly. If you do not want an item to shrink, then you can specify flex shrink 0. You can also specify higher numbers to a certain item's shrink at a higher rate than normal, or to make certain items shrink at a higher rate than normal. Here's an example. Note that we've also changed the flex basis for reasons that will be explained shortly. If you shrink your browser window, you'll notice that 2 never gets smaller than the given width of 250 pixels, even though the flex grow rule would otherwise specify that each element should be equally sized. Okay. Okay. An important implication to notice here is that when Wait, let me have a look at this first. Display flex. Flex 1 auto. It's fine. Flex container with a div, the divs. And one with a 2 has a flex shrink of 0. Width is 250, height is 100 pixels. Okay, it is important. An important implication to notice here is that when you specify flex grow or flex shrink, flex items do not necessarily respect your given values for width. In the above example, all 3 divs are given a width of 250 pixels, but when the parent is big enough, they grow to fill it. Likewise, when the parent is too small, the default behavior is for them to shrink fit. This is not a bug, but it could be confusing behavior if you aren't expecting it. Flex basis sets the initial size of a flex item. So any sort of flex growing or flex shrinking starts from that baseline size. Okay. The shorthand value defaults to flex basis 0%. The reason we had to change it to auto in the flex shrink example is that with the basis set to 0, those items would ignore the item's width and everything would shrink evenly. Using auto as flex basis tells the items to check for a width declaration. Wow. I'm going to have to come back to this to remember that fact. Just gotta say hi to the peeps that joined the Discord. Important note about flex basis. Okay, so firstly, flex basis sets the initial size of a flex item. So any sort of flex growing or flex shrinking starts from that baseline size. I think I understand, right? Oh, is this an iframe? Can I actually go in here? Yeah, I can. $270. For pix border, 270, 100. Right, because you're growing. 486 and 100. $118. So is this? Sure. Important note about flex basis. There's a difference between the default value of flex basis and the way the flex shorthand defines it, if no flex basis is given. The actual default value for flex basis is auto. But when you specify flex1 on an element, it interprets that as flex110. If you want to only adjust an item's flex grow, you can do so directly without the shorthand. Or you can be more verbose and use the full 3-value shorthand, which is also equivalent to using flex auto. Now that's a little interesting in the sense that you got tailwind, flex. You got tailwind flex, flex auto is 1-1 auto. Flex 1 is that. Flex 9. Using flex initial to allow a flex item to shrink, but not grow, taking into account its initial size. Flex 1 to allow a flex item to grow and shrink as needed, ignoring its initial size. Use flex auto to allow a flex item to grow and shrink, taking into account its initial size. Mad. That's cool. Won't lie, that's pretty cool. Ooh. That's also pretty cool. Very cool. Okay, what is flex auto? If you noticed, we mentioned a new flex shorthand, flex auto, in the previous note. However, we did not fully introduce it. Flex auto is one of the shorthands of flex. When auto is defined as a flex keyword, it is equivalent to the values of flex grow 1, flex shrink 1, and flex basis auto, or flex 1-1 auto using the flex shorthand. Note that flex auto is not the default value when using the flex shorthand despite the name being auto, which may be slightly confusing at first. You will encounter and learn more about flex auto and its potential use cases when reading through the assignment section. In practice, you will likely not be using complex values for flex grow, flex shrink, or flex basis. Generally, you're more likely to use declarations like flex1 to make divs grow evenly, and flex shrink 0 to keep certain divs from shrinking. It is possible to get fancy and set up layouts where some columns relate to each other in a specific ratio. So it's useful to know that you can use other values, but those are relatively rare. Read W3C's flex section to understand the basic values of common flex shorthand values. Okay. Sure. Basic values of flex. This section is informative. The list below summarizes the effects of the 4 flex values that represent most commonly desired effects. Flex initial, equivalent to flex 01 auto. This is the initial value. Size of the item based on the width height properties. Ooh, hello Becca. Nice of you to join. What you been up to, actually? It's been like 2 days, right? "10-hour learning stream? Fuck me, I'm done after 1 hour, yeah. I mean, it's not all learning during the 10 hours. I'm eating as well, sometimes. And going to the gym. But technically, actually, I went for a nap instead of my gym session today. Just because I haven't slept enough. So I'm going to sleep properly tonight. Like, actually. But yeah. It's more like a 6-hour stream, I would say. Or 6-hour learning stream. But we're good. Size of the item based on the width height properties. Still pretty long, motivates me to do better. That's what I'm here for. That's what I'm here for. Hopefully, yeah, it brings some value there. But yeah, don't sit for too long. That's one thing. Apparently sitting is the new smoking, as they say. And I'm just about done anyway. Maybe in the next less than 30 minutes. Just before I understand all of this. Just so that I understand all of this. AD. Ooh. Wow, that's a 34-minute video. Thank you, Kevin Powell. I will probably watch this at some point, but for now, we're just gonna save that.
Sometimes it's magical and it just works and does what we want it to do, and other times it doesn't quite do exactly what we ask. It starts doing some strange things, and it can be hard to understand exactly why. You start throwing some alignments or justifications.
Man, when you forget your key bindings and you have to do this. Oh wow, Kevin Powell has grown old, hasn't he? Let me stop this. This is probably like overlaying really badly. Oh. What in the world, man? I don't know my key bindings. Save to watch later. Okay. I'll watch that later. What are the three values defined in the shorthand flex property? Flex basis is the third. Flex, grow, and shrink. And then basis. What are the three defined values for the flex shorthand auto? 1 auto. Nice. Okay. Going back to this. Flex initial, this is initial value. Size the item based on the width height properties. If the item's main size property computes to auto, this will size the flex item based on its contents. Makes the flex item inflexible when there's positive free space. It allows it to shrink to its minimum size when there is insufficient space. The alignment abilities on or order margins can be used to align flex items along the main axis. Alright, flex auto, equivalent to flex 1 auto, sizes the items based on the width height properties but makes them fully flexible so that they absorb any free space along the main axis. If all items are either flex auto, flex initial, or flex none, any positive free space after the items have been sized will be distributed evenly to the items with flex auto. Flex none equivalent to 0 auto. This value sizes the item according to the width height properties but makes the flex item fully inflexible. This is similar to initial except that flex items are not allowed to shrink, even in overflow situations. Wow, epic. So flex positive number 10. That is my concern that I was confused about. So this has to be just positive number 10. makes the flex item flexible and sets the flex basis to 0, resulting in an item that receives the special proportion of the free space in the flex container. If all items in the flex container use this pattern, the sizes will be proportional to the specified flex factor. By default, flex items won't shrink below their minimum content size. The length of the longest word or fixed sized element. To change this, set the min width or min height property. Wow, I'm gonna have to go back to this at some point in my future when I need real understanding. Here we go, here's another long flex overview, which I will go over. Just means I'm very close to finishing G, and AG will be next. SD, G, C. Axes and alignment. Very close, very close. Let me sit down. Baseline widely available. The Flex CSS shorthand property sets how a Flex item will grow or shrink to fit the space available in its Flex container. Flex 1, Flex 2, see Flex 1, Flex 2, Flex 1 30 pixels, Flex 1 100 pixels, set as a default. Sure. Constituent properties. This property is a shorthand for the following CSS properties. Flex, grow, shrink, basis, syntax, keyword values, flex, auto, initial, and none. One value, unit list number, flex grow, flex basis, is then equal to 0. One value, width, height, flex basis. Huh, that's mad. 2 values, flex grow, flex basis. 2 values, flex grow, flex shrink. 3 values, flex grow, flex shrink, flex basis. This is all very intuitive. Global values: inherit, initial, revert, revert layer, and onset. The flex property may be specified using 1, 2, or 3 values. That's fair. It's valid, logical. Values, initial, order, none. Initial. Right. Order: the item is sized according to the width and height properties, but grows to absorb any extra free space in the flex container and shrinks to its minimum size to fit the container. This is equivalent to setting flex 1 order. None: the item is sized according to the width and height properties, is fully inflexible. It is neither shrinks nor grows in relation to the flex container. That is equivalent to setting flex 0 auto. Flex grow. Flex shrink, flex basis. Description. Right, yeah. Auto, initial. Yep. Auto, none. Yep. Initial, none. Oh, madness. And 4, 2, and 1. Originally just 4, 2, 1, I see. That's a very good demonstration. I am loving this demonstration right here. By default, flex items don't shrink below the min content size. To change this, set the item's min width or min height. Yeah, it doesn't shrink below that, which makes sense. Wait, so if I actually do this and then go to try and see this item right here. 6.5, 0.13. So that means, right, we can grow and shrink it all. And we can go into 0, right? But you still have a padding of 6.5 or 0.5 EM. And let's just set this to 0. And set this to 0. How does that look? Right. That's what I expected. That's very sick. Very sick. Okay. Formal definition. Examples: setting flex order This example shows how a flex item with flex order grows to absorb any free space in the container. I mean, is that not obvious? JavaScript. The flex container contains two flex items, flex order, flex initial. Flex initial item takes up as much space as its width requires, but does not expand to take any more space. Alright, done. Go back. We're up to axes. And there's 10 minutes left. I think I'll keep it. I'm going to keep it done for now. I'm going to be done for now. But now it's a little bit of time that I gotta spend in the terminal just to familiarize myself with where I use Flexboxes in my scheduler app. React mentions is still not a thing. Very confused. React mentions. And yet React mentions. Unless that's just not how you use it. So just gonna have to think. Just gonna have to think. Nah. How do I think about this problem? What do I think about this problem? My thinking is, I don't worry about it. And instead, look at some of the components which are more important, such as the navbar. And looking at the navbar, it's quite a few things actually. So space rn, 15j, open it up. So path and task, sure, and then navbar, set nav index on handle click, disclosure button. This is using headless UI. I'm fine with it being headless UI, but flex. Right, so we do use flex there. Let's have a look at where we have flexes. Flex 1, flex shrink 0. Flex. flex height of 16. Max width XL 7. Small PX 6, large PX 8. I'm not convinced. Large PX8. Okay. Alright. We're good. We're good. I'm gonna call it a day. Just looking at some of this. I mean, let me try run this. All right. I need to turn on Docker. Flex. BG board B. MX Auto. Margin. PX. Padding on the X is 2. And small padding large padding. Really? I'm assuming that's how I understand that problem. So, assuming I remove that, okay, I probably need the small padding. No, that's not what I need. That's not even the reason. It's not even the reason. Redo. Redo. Undo. Okay. That's cool. So that's not the reason, then what is? So it has to be the next thing down, which turns out to be, let me just highlight this, right? Surely. No. When I move it across, that's when it stops shrinking. That's like the maximum. It sets a maximum. You know what I mean? Flex H16, is that? What's out of that? Mm-hmm. Damn. Alright, right. Well, shall I call it a day? Yeah, I'm gonna call it a day. Alright. Thank you all for sticking along. And tomorrow I'll be at uni, so it won't be as eventful on streams tomorrow. And actually, yeah, I just won't be streaming at all tomorrow because gonna head to somebody else's house afterwards. So yeah, we're gonna call it a night. We're gonna say good night. I think I definitely spent a lot of time today learning about one of the binary search Leetcode questions. Sorry, binary tree, followed by Flexboxes in general, and I've also learned about Flexboxes now tonight, and now also the study which I did for uni, which I guess the highlight for that was to get through a few intro lectures. Yeah, we got through 2 intro lectures and we got to read some content as post readings. And if I go to today, we also did mainly the lecture readings. Finished this up. Yeah, we're good. We did good work. Alright, good night guys. Ciao. Bye bye. Bye bye. Bye bye. Have fun. Work hard.